Welcome everybody. Whose first melcss is this? One, two, oh my gosh, quite a few. Well, welcome. First, I want to thank our host, Zach, and Atlassian. Thank you so much. This is a fantastic opportunity. And before I get into my talk, I also want to encourage everyone else to, if they are open to, coming and giving a talk. I think Zach would have said that earlier as well.
Please help.
This is officially my first talk as a developer. So thank you for being my captive audience. I have been a speaker in my past life doing other things, so it's not my first time doing public speaking, but hopefully I've come with an exciting topic for you guys. If the name doesn't give it away, I'm going to be talking about all things related to colour, what happened when I did something probably a lot of people wouldn't want to do, and what it taught me about colours, and maybe it'll be useful for you when you do some of your front-end developer work. Now, there's going to be a couple of prompts here and questions. Feel free to answer. If you have any more specific questions at the end of the talk, I'll be around at the pub or here. So feel free to come up and ask me. I might not know the answer and I might go and look into it as well. Who am I? I'm Asbed. It's an odd name. It's an Armenian name if you're interested in the heritage. Some people know me as Dots, thanks to Zach. But that's my Discord pseudonym. So if you see Dots online, that's me. What do I do? Well, I've had a long history of work in tech, particularly in the hardware industry. I've worked for some of the larger manufacturers doing things related to service desk delivery and automation, deployment. But ever since I was young, probably 12 years old, 13 years old, I remember my first line of code was probably HTML and CSS in Notepad. And that's what I've always wanted to do. That's been in me. So 2 years ago, I made a monumental shift in my life and changed things. And I'm on a path to be an engineer. And that's had some really exciting turns, a lot of cool sort of projects along the way, and I've met a lot of interesting people like you. So that's me in a nutshell. That's my website. From there, you can find my LinkedIn, et cetera, et cetera. Now, if you have an actually moment today where something I've said is like, actually, this is the right answer, feel free to come and let me know. We're not perfect, no one is, but that's why we are all engineers, right? We want to learn, we want to get better. 100% there's probably something that I've misread or misquoted. A lot of research went into this, and you can see all the sources at the end. But yeah, obviously, I'm really open to actually moments because that makes me better as well. Okay, so how did it start? Does everyone know this meme? It all started when my mum met my dad, no? So it all started when Tailwind, one day I was sitting here and I was like, everyone knows Tailwind, right? Does everyone know Tailwind? If you don't know Tailwind, utility-based CSS, really cool. I really enjoy using it. I know it's a controversial topic. Started when Tailwind met my dad, JavaFX. Everyone know JavaFX? No? One person, two people? No. It's better you don't know it, trust me. Java, okay, so Java has options around how you do UI and front end. And that's why I called this title of this talk a cursed experiment. JavaFX is like a pseudo way to do HTML. It's got its own declaratives. It's got its own ways of putting in things like classes. But if you know enough about HTML and CSS, you could probably make a Java application, believe it or not, with frameworks like JavaFX. And I'll show you. This is what it looks like. So up the top there, that's like an element, like a label element. You will see there's things there that are like CSS. Instead of class, it says style class. Instead of ID, it says FXID. Don't ask me why, but that's the way Java does it. But I really got over writing CSS for this application I was building. And I was like, I just want Tailwind. I want Tailwind. I want to write my classes like I do in Tailwind. How do I achieve this? And one thing led to another. It's not part of this talk, but I basically built a theme engine. It's called Jailwind. It's essentially JavaFX Tailwind. But one thing led to another, and it went into this whole sort of rabbit hole. But we're not here for that. We're here for, yes, I am mad, by the way. We are here for why. What happened? There was a question that came out of this for me, and we'll come to it. Before I do that, though, does anyone know, I don't even know if this is the right answer, but How would you write a color in CSS? Zach, you first.
I guess a hex.
Hex code. Any other answers?
RGB.
sRGB.
RGBA.
RGBA. Any other answers? HSL. Good one. That's what we're talking about. Yep. Just name the color. Yep.
Okay, lab.
There's quite a bit of ways to write a color in CSS. And I don't know if I've gotten all of them, to be honest. I think I counted 26, 27. I know it's a bit small there, but some of the more interesting ones, we'll talk about OKLCH towards the end. Inherit. Did anyone know you could inherit colors? Zach gave a talk last time around agents and those being sort of base classes. You can actually inherit colors from those agents. Canvas text, OS level colors. I didn't know that that existed when I was looking into this. Mind you, I haven't tested all of these, but you know, I've got some good sources that say there's quite a few ways you can do a color. So yeah, why? Does anyone know why? No, we'll get into it. So when I was going through this and I was building my Jailwind, if you've ever used Tailwind, you know that you do your colors, you go 500, 600, 700, 900. And intuitively, it goes from a lighter shade to a darker shade, right? Or if you're in the, I think it's the dark mode, it's the opposite. Why? Why do I lean towards a hue saturation value color picker when trying to pick a color on my computer? Does everyone know what I'm talking about? A HSV color picker? You know that big canvas you see where you move the dot around and you pick the different colors and then you can intensely put it up and down. Why do we lean towards that? And that's what this talk's going to be about. It's going to be about how this all came about, what's some of the science behind the colors, and why we do these sorts of things. So there's what I was talking about there, the color picker. There's some links there if you want to go check it out. That's a pretty good color picker, actually. It was probably one of the better ones I saw online. And then that's from the Tailwind documentation. That's what I was talking about with the numbers there. All right. Bit of trivia. Who's this guy and what has he got to do with colors? Does anyone know? Okay. That's Isaac Newton. So colors have a very long dated history. It's interesting. If you start to look at when humanity started to write about colors, you can go back as far as, and I've got notes here, by the way. I don't memorize this stuff. Some of this stuff is very hard to memorize, but I think one of the oldest color literature documents was Aristotle. Aristotle's on color. That's 322 BCE. But a lot of the concepts related to color and a lot of the things we'll discuss today actually come from this guy over here, Isaac Newton. And yes, he loves CSS. I don't know if you guys noticed his hat said I love CSS in the title slide. He still loves it. So he said that white light is composed of a spectrum of colors. And he named them, red, orange, yellow, green, blue, indigo, violet. A bit of trivia here. Indigo is technically not in the spectrum. It's a fake made-up color. It's actually the combination of two waves combining to make indigo. But he added it in because he wanted it to be the musical notes, do, re, mi, fa, sol, la, mi, te. So Newton was the first one to discover color from white light into a spectrum. And this is going to be very important because it comes back to our perceptions of color. So I had a really big argument with my partner over defining this. She's studied biology and neurology and she's doing psychology. And I like numbers and binary and bits and bytes. I'm like, oh, color's just this. And she's like, no, color is this, color is that. We came to the realization color is the translation of light sensed by the human eye. So it's not just a sense. You also perceive it in the brain. And that's very important because color is actually made up of 3 wavelengths. We've got red sensing wavelengths, green sensing wavelengths, and blue sensing wavelengths. And the eye itself has these cells in the back of the eye that are sort of more aligned to your red sensing, red and green, and blue. That means that the human eye actually sees more variations. We technically peak in green. We see more variations in shades of green than blue. Blue is the hardest one that we can actually see the difference of shades in. And again, I'm trying to link this biology back to, how you build your UIs and, where you use blue versus green versus red, right? So you have to think about it in the sense of biologically, we've got these quirks. We have the difficulty to be able to see blue, whereas green we will be able to perceive. I think a couple of weeks ago, someone brought out a mini game where you could actually try to see how good your eyes are by pressing where the colors change. It's pretty cool. If I find the link, I think Zach's got it, put it on the Discord later. But that can give you a good idea of how the eye perceives colors. So what happens? Light, the photopigments, the light comes in, it hits the photopigments. That gets absorbed. It starts a chemical reaction. That changes the membrane potential, creates an electrical signal, and then that's passed along through the optic nerve and then into the brain. So you sense light and then you perceive it, in a nutshell. So here we are, a bunch of people working on computers. We've got these imperfect eyes. How do we standardize? What do we do? Well, there is a standard for that. This organization here, I am not going to attempt to pronounce the French pronunciation of the organization's name, but the International Commission on Illumination. It's actually a very old organization. It's over 120 years old, I think. They are responsible for all things standard related to light, color, and imagery, particularly image technologies. Now, it's such a broad field, and some of the things we're going to discuss after this slide aren't even going to touch the surface of this topic, right? This is a really good quote I found online, and when I was going down this rabbit hole, it reminded me that, people have dedicated their lives to this. Here I am doing a 20-minute talk on it, right? So if you are interested in this stuff, it can get very deep, it can get very specific. I think from my perspective and what I would impart on you based on my research, just remember that when you're building these things, even me, I have bad eyes. When I take these glasses off, I have difficulty seeing things. Sometimes I have difficulty in looking at colors on top of other colors. That's what it all comes from. It comes from these biological quirks that we have. And understanding some of it can go a long way. So, that organization before that I mentioned, they created a standard for what we would say is a representation of the full gamut of human color perception. It's impossible to put this on a screen, by the way, and you're going to find out why. But this is basically a high-level representation of what a human can see, right? You will not be able to technically put what we can see on a screen. So there's a couple of elements to this. Don't worry, I don't expect you to be able to read this chart just by putting up a photo. We've got the what's called the spectral or the monochromatic locus. So that's that big curve around. This is representing the physical measurement of light in wavelengths. Okay, so remember light is wavelengths. This represents the wavelengths. Remember how I said we peak in green? That's our peak up there, the green. That solid curve in the middle, think of it as the color of heat, right? It's called a Planckian locus. If you think about a fire burning, it gets hot slowly, gets to white, and then it comes back down. That peak point, white, is considered white in this representation. So it's a path that an incandescent black body would take in that color space, right? We talked about color naming conventions earlier. Someone said you can just write purple. There is actually a system, apparently. It's called the Munsell color system. I don't know if CSS has adopted that standard for naming colors, but it is a standard in terms of naming colors out there in color science, the Munsell color system. So you see along this graph, there's green, yellowish green, that's an official title, blue, purple, reddish purple. So you can actually say these things and say, no, it's a real color, it's on the Munsell system. This is the fake news I was talking about. So this bottom line here that doesn't have the black line, the wavelength, that is actually an outer boundary that's emitted. These colors don't exist as a single wavelength in nature, right? These are colors that come together. It's usually the red and that sort of ultraviolet purple down the bottom there. And last but not least, down the bottom, that's the Kelvin temperature of that Planckian locus that I mentioned earlier. It's a lot to digest, I know, And you don't need to know this to put a color in CSS, but it's fun to know. So, does anyone know what these two numbers represent?
Is that like the number of colors that a person can receive based on, like I know women can receive more colors than men. So does that
Which one's the more one?
women?
No, like which out of these, what would you say 100 million is, for example? That's okay. I wouldn't have known before I did this talk either, right?
16.7 million is 24-bit color.
Aha! Someone knows this 24-bit color. Perfect, yes. So, 100 million, technically it's between 1 to 10 million colors that the eye can actually perceive. But when you start to look at colors in different lights and shades and whatnot, it can get up to 100 million combinations. To the point earlier, the 16.7 million is the limitations of some of the color spaces that are out there at the moment because of the bits and bytes that go into it, as mentioned earlier. Bit depth, actually. So it represents about 8 bits per, it represents 8 bits per channel, 8 red, 8 green, 8 blue, 24 bits in total. And then that goes to a maximum number of distinct colors ranging from 0 to 255, right? So that chart earlier, guess what? A lot of the color spaces we use barely touch that chart, right? I wasn't around for 1954 NTSC television, but apparently it was a pretty life-changing moment when colour TV came around and grey suddenly went to colour. It's very interesting how they did that if you're interested in looking at the spec on it. You can imagine there, you know, everyone was watching black and white television and all of a sudden colour comes through the signal. sRGB is what we're primarily going to be talking about today. That's what we use on most computers and on the web. Then you might have heard of some of the other ones like Adobe Color. Anyone dealt with P3? Anyone developed and wrote a CSS color in P3? Interesting. Okay. Yeah, P3, who has a MacBook? You all have P3 displays. So most smartphones, MacBooks, they all have P3 displays. They have a higher color gamut. If you're writing web apps and for some reason you put in a P3 color code, probably going to have some angry, like older device Windows users going, why is the contrast so weird? And we'll talk about that in a second as well. And then Rec 2020, which is the Ultra HD, 4K, 8K display color standards. Now the triangles there, I don't know if it's easy to see on this display, which I'm assuming is sRGB, but that white triangle is what we are working in the web mostly, the sRGB triangle, right? And then as you get these better displays out there, you're going to get all these different colors that, and every user is going to have a different experience depending on what standard you use. So Newton, he's sitting there. He's got his CSS mug. He's coding. I reckon Newton would have vibe coded. I don't know. I feel like he would have definitely used AI a little bit. But he's sitting there and he's like, well, I've got all these users. One's got a MacBook, one's got an iPhone, one's got a Lenovo, which is what I've got. How do I get them all to see the same colors when they go to a website? Thankfully, there were some researchers at HP and Microsoft who submitted a spec to W3 back in 1996. It's called a Standard Default Color Space for the Internet, sRGB. Fascinating read. Interesting that whilst this was what was put forward, this isn't actually what was adopted in the end. It was a variation of this. But there was a couple of things here that I think are important to note. They wanted to do 3 things. They wanted to improve color fidelity in a desktop environment. They wanted to create a uniform standard for software development. And they wanted to confidently communicate colors with minimal overhead. So what that means is my laptop, your phone, your projector, everything, when we say it should look purple, right? In a like that's the simple way of putting things. Because back then there was HP devices, there were other devices that probably aren't on the market today, different color standards for their monitors, different color standards for software, You had Adobe people needing Adobe hardware to do specific things for print. So they came up with the standard. And that's what we actually have been using ever since, sRGB. What they wanted to do, it's like a parametric system where things are defined, right? When things are defined, that means that the variables that me and you would be our hardware, those are standardized to a certain point where both our hardwares would be able to communicate. So they defined white, red, blue, and green as part of this system. That was to the Rec 709 standard back then because it matched the phosphors in most CRTs. I know it's a bit geeky, but you can look it up later if you want. I am not going to explain this, but they defined gamma transfer function. There's a lot of mathematics involved. There's a link in the articles, you can go have a look at it, but basically they standardized the way that Planckian locus works on CRTs. And then they also defined a variable, which is us, the standard observer, the human being. What are we most likely going to be using our computer in? Like, which environment are we going to be using it in? How's it going to be used? What's the viewing environment like? And it's actually quite forward-thinking, that one, because it ties to a lot of standards that we have today. And if you think about it now, most of the time we do front-end and UI design, we think about the standard observer. We think about, who's going to be using this and what are the variations of users that might be using this. Could they be using a keyboard or a phone or a tablet? In a lot of personal projects, I think we often neglect the tablet, but then I talk to a lot of people over the phone who use tablets. So, those are sorts of things that they were thinking about back then. This is what the original syntax looked like. So there's some things there that might be interesting. The only thing here that I really wanted to talk about was rendering intent, because this is very important. This is like, rendering intent was this idea, and this was defined by the ICCC, these standards: saturation, perceptual, absolute, and relative. That's ICCC standards for rendering intent. That's defined by them, these terms. Perceptual means that it's best for photos, so compressing gamut. Relative colorimetric is ideal for things like logos and vectors and matches the exact gamut. Absolute colorimetric means no adjustments to a gamut, and saturation is used for things like charts and graphics, right? This is the standard they came up with, and I would say that this idea has come back with some of the new standards like OKLCH, which we'll slightly touch on. How's it going? Have I still got everyone? Any questions so far? Thank you. All right. So, what happens, I'm not going to say that, what happens when we change an RGB slider value? This is Troy from Hitchhiker's Guide to Digital Color. So Hitchhiker's Guide to Digital Color is a great little resource. You can open that link, read one little article a day, and learn something new about digital color. But you're quite literally increasing or decreasing the emission intensity of one of the three RGB lights. That's it. Putting up red a little, putting up green a little, or putting it down a little. And when you do that to a hex color, it doesn't look great. Has anyone tried this? Zach has. Has anyone tried to manually mess around with RGBs? Yeah, and tried to get a consistent result? So you can imagine when I was building Jailwind, and I was building my 1, 2, 3, 5, 7, 9, this wasn't going to work because I wasn't going to have consistent results across different shades, and I was losing things like colorfulness and brightness and saturation. So that's what happens when you start to mess around with sRGB. And the reason why is this is what sRGB looks like mathematically. So sRGB is a cube of colors. You essentially map all these colors onto the cube, and your coordinate system tells you where to go in the cube. And one corner is green, one corner is red, purple, blue, white, and the back that you can't see is black, right? So if you have a system where you're going from red +1, +1, +1, you're not necessarily doing things like linear interpolation or anything like that. You're just moving around in this big cube of colors, and there's no consistency depending on where you are. So when you map that to this system, by the way, the term for this is Cartesian coordinate system, if anyone's interested, but let's just call it the cube, right? This is what you get. You're not going to have like this uniform movement of color. It doesn't work. If you want to build the cube, you can. It's a couple of nested for loops. Don't do it with the actual number of colors available. You'll break your computer in JavaScript. But yeah, that's what it looks like in code if people prefer to look at it from a code perspective. But the artistic way to look at colors is this. This is the painter's color mixing terminology. And remember when I said earlier, why do we lean towards HSV? Naturally, it's because we do this. This is the intuition behind it. We take our color, we go red. Oh, I want to add a little bit of tint. Move it up towards white. I want a bit of tone. Move it left and right on the slider, right? I want it to go a bit darker in shade. Move it down towards black. So this mixing terminology is actually what inspired HSV, HSL, HSI, right? Hue, saturation, lightness, hue, saturation, intensity, hue, saturation, chroma, color. That's where it comes from. It comes from this methodology. And what that looks like is this. We're taking our cube and we're turning it into a cylinder, right? We are mapping that coordinate system, taking that sort of standard movement across our big cube, and we're making it easier to navigate because now we're going up towards white or down towards black or in the middle towards the chroma or outer towards red. Now, this might not look familiar to you right now, but I promise you it's familiar. This is what it is, right? When I talked about that color picker earlier, that's what you're doing. It's the cube unrolled. The cylinder unrolled, right? And you might have seen the top of the cylinder in some of the color picker systems. Sorry, I just realized this mic goes a bit louder when I get closer. You might have seen the top of the cylinder in some of those color systems. You might have seen the side of the cylinder in some of those color systems, but that's what it is inherently. Some of the terms you'll see in HSV, or HSC or HSI, these are more relevant to helping you understand what hue, saturation and lightness are. You don't need to remember these. The capital M is a max, like the maximum number in red, green and blue. The lowercase m is the minimum number in red, green, blue. And your chroma or your color is usually your highest and your lowest difference. These are more the math behind what's going on, but not really necessary, to be honest. So the angle of hue. You know, like when you're picking the hue and what's that number? Well, it's the angle. That's what it is. 0 is red and 360 degrees is red. So you're going from one side of red to the other. So when you unroll that cylinder, when you're picking hue in a HSL or a HSV color picker, this is what you're doing. So if you have some sort of an image in your mind of where the colors are, and guess what? That's the rainbow colors. So I think the acronym's ROY-GB, something like that. Red, orange, yellow, green, blue, purple, violet, indigo. Yeah, so close enough. You'll be able to, blue, violet, indigo, ROY-GBV. You'll be able to know roughly where your angles are. So that's hue. What's saturation? Well, this is a tough question to answer. If you Google what is saturation when it comes to color, good luck. There are so many takes on this, depending on what field or industry the person you're talking to, they're going to give you a different answer. The one I came up with that I thought did it most justice for developers and front end and being able to explain it to like an engineer and the team is it's just the colorfulness of an area based on its brightness. If you give any other explanation, I think people will just lose. They won't figure it out. It's very...
The original definition was literally how long you let the fabric soak in the dye. It's
how long you...
saturate.
Okay. How long you let the fabric soak in the dye. I like that.
So it's how
I like that.
you get the fabric
Yeah.
That's how bright the color is.
Yeah. I like that. I like that as well. But again, it's such a mixed bag online. I went with this for now. But the math behind it is the that chroma, that intensity, right? The capital M minus the lowercase m. And then this one is the last value. So for those who've seen HSV, and then you might be aware there's also HSL and HSI. The literal difference is the weights, the weighting you put on the RGB values. In HSV, the weighting is done towards the max, the strongest color component. In HSL, the lightness is the average of the least saturated components. And in HSI, it's just a true mix of all three components. And that's the way you determine the difference, essentially. In fact, that cylinder I showed you earlier, you can Google that cylinder across these three different options, and you'll see different ways that that cylinder is represented as well. So going back, it's a bit hard on this projector. Going back here to that thing I was talking about earlier with the values and the weights. So I put in factors associated with lightness and intensity as my differentiator in my theme engine. And I was able to create these color palettes based on base or seed primary colors that would go lighter and darker, and that would feel uniform, no matter what color you chose, whether it was a green or a blue or an orange or a purple. If I did that with sRGB using just standardized variations in R, G, and B, I wouldn't have had the same results. It would have looked very different in the greens, very different in the reds and the blues. And that's basically it. Now, OKLCH, I can't finish the talk without talking about this. We spoke about the... Oh.
Is that better?
Much better, thank you. So we talked about the variations in color, right? And being able to create a standardized color that you could render on multiple different devices. So in sRGB space, you are highly limited in the colors that you can put in front of a MacBook or an iPhone these days. It doesn't look as nice. You're going to not be able to use the full color gamut of the device. And a lot of the new standards that were between sRGB and OKLCH wouldn't give you consistent results across the devices. You would end up having like a purple look red on a sRGB space, as an example. And the reason for that was the way that those triangles were mapped and the fallback values to go back down to sRGB. So you saw the Cartesian coordinate system, you saw the cube, you also saw the color gamut mapped with the triangles. If you were like to go to the peak of a green and then map it down to sRGB, you wouldn't land in the same category of green, essentially. So someone really smart took OKLab and HSL and put it together. That's basically what OKLCH is. And they were able to basically bring these devices together to a certain degree. And the reason for that is this. This is what the OKLCH color space or that 3D representation looks like. So if you were to go to the peak pink or the purple and you were to drop it down like this, see those lines? It's a bit hard to see, but it's in the top right corner there, those lines over there. They are like the different color spaces that are mapped out. So OKLCH is the full shape. You've also got like sRGB in there, and then you've also got P3 in there. P3 is a bit bigger. So if you go peak purple and you drop down to P3, you're still roughly purple. Or if you drop down to sRGB, you're still roughly purple without having the issue of mapping these coordinate systems that don't end up in the same color. I think Tailwind V4 is all defaulted to OKLCH. So if you're using Tailwind V4 and you're using the standard colors and you're not doing any custom theming or anything like that, you're already using this. A lot of modern UI libraries that are styled should technically be using this. Obviously things like ShadCN, you style it yourself, so don't worry too much about that. Yeah, OKLCH, if you haven't used it yet, I would recommend having a look if you have a smaller project you want to test it on. Most IDEs will be able to give you like the color, hex color equivalent to what you're using, depending on the way you plug in your IDE, but yeah. Highly recommend checking it out because that's the future. You'll then be able to ship your website or your design for an iPhone, a MacBook, or a ThinkPad from 2015 and have similar consistent results. And as I said, it worked for me with Jailwind, but I didn't use OKLCH. I made my own OKLCH. So that's what happened in the end with my Jailwind design, my cursed CSS experiment. It ended up giving me a whole heap of perspective on human vision, on computer science, and also on the quirks of hue, saturation, and lightness. If you did enjoy this talk, I've written an article on it with a lot more detail. You can use that QR code or check it out on my website, or you can just connect with me and ask me questions later. That's pretty much it. Thank you.